Is it possible for two water molecules to react? If you ask me this, I will also ask you whether it is possible for two women to wed themselves. Yes, it is possible. But when two women wed themselves, one of them will wear a suit and the other one will act as the bride. And in the business of marriage, as one is acting as the husband, the other one plays the role of a wife, yet they are of identical sex. In the same way, water can react with the same water molecule. It is experimentally proven, so it is not a theoretical fabrication. It has an experimental proof that water can react with water. See what happens. As two women wed themselves, one plays the role of a husband, the other one plays the role of a wife. That is exactly what happens in this situation. This particular water plays a role of an acid, and this plays the role of a base. And recall, a Bronsted acid is a proton donor, and a Bronsted base is a proton acceptor. In this case, this particular acid will donate a proton. One of the hydrogen ions will go to this, and we are going to have OH minus. This one becomes OH minus. And this one becomes H2O plus. This reaction is called auto-ionization of water or self-ionization of water. Experiment shows that at room temperature, out of 500 million water molecules, one is capable of auto-ionization. But auto-ionization cannot take place in isolation. Two molecules of water must be involved. Therefore, out of 1 billion molecules of water, two molecules are capable of auto-ionization to form hydroxide ion and hydroxonium ion. Let me show the structural equation for proper understanding. So when these two come together, it means that this bond will break as this oxygen, one of the oxygens will assume a greater electronegativity than the other oxygen. As this oxygen picks the electron, hydrogen will be attracted to this particular oxygen. And what do we have? We now have H bond O minus plus H bond O bond H, dative bond H. This is called hydroxonium ion. This is just the structural equation representing this same equation. So that is auto-ionization. What is the takeaway from this particular reaction? What is the takeaway? Water is regarded as an amphiprotic substance. Water is amphiprotic. Amphi means dual behavior, meaning that water can act as an acid. It's possible for water to act as an acid and also as a base. Look at it here. Water as an acid and water as a base, meaning it can release a proton, it can accept a proton. How do we know? Now, water can react with hydrochloric acid. You know, this one is purely an acid, a strong acid for that matter. So, we know that water can act as an acid, but immediately when it meets a stronger acid, it will submit itself under the authority of this stronger acid and remain a base. So water acts as a base automatically whenever it meets an acid in a reaction mixture. So what happens? As an acid, this particular acid will donate a proton to water, and water accepts a proton as a base. So what do we have? What we have is hydroxonium ion. When water accepts the proton, it becomes hydroxonium ion, and we have a chloride left. This is where water is acting as a base. We also have another situation where water acts as an acid. Let's go. When the same water encounters a stronger base like ammonia, what happens? You know that ammonia is a strong base. Now, water, maybe it wants to act as a base, just like this, but it now encounters a stronger base. What happens? It will submit itself under the authority of this stronger base and begin to assume the function of an acid. So as an acid, what happens now? Water will donate a proton to this base. So look at it. Water will donate a proton to ammonia. And we have OH minus left. And this ammonia becomes, what does it become? Ammonium ion. It becomes ammonium ion. So that is the takeaway we get from the auto ionization of water. It now reveals that water is amphiprotic. Meanwhile, whenever it meets an acidic medium, it acts as a base. When it meets a basic medium, it acts as an acid. But when water meets another water molecule, there is a possibility that one will act as an acid and the other one as a base. But in this case, it is very, very rare to happen, meaning that in every 1 billion molecules of water, only 2 are capable of auto-ionization. I hope you got value. If you did, comment, like, and share this video so that it will reach the students and teachers that need it for their instruction. Keep on watching Chemistry Made Easy and do have a wonderful day. See you in the next video. Bye.
Stay tuned on Chemistry Made Easy. Follow and subscribe.